Okay, so the last section we're going to talk about is finance. It's called Mathematics of Finance, and it's just another kind of real-world application of logs and exponential values, that kind of thing. We pay interest for the use of money over time, like in your bank account or a 401k or property. If you buy property, mortgage has an interest rate on it. So we borrow money with interest rate, a car loan, house loan, all of those things. Okay, so anyways, I'm just going to give you some of the three main equations we're going to use in this section. So the first one is when interest is compounded annually. Okay, so here's the equation for that. So A equals P 1 plus R to the N. So the principal, so the initial value you start out with, the initial value you put in your bank account or whatever, that is P. R is the rate, and we always want to write that. We're going to express as a decimal. You always want to write it as a decimal. Okay, and then N is the number of years. Okay, so this is if the principal P is invested at a fixed, P is invested at a fixed annual rate. R calculated at the end of each year, and then the value of the investment after N years is A. Okay, so that's the equation here. Little box around it. Okay, the next one is the same equation, except for we are going to compound it so many times a year. So you might hear like quarterly, or it could be daily, it could be monthly. Okay, so the equation looks very much the same, except we're going to do it k times a year. So we're going to divide the rate time divided by the time of year, and then we're also going to have to multiply the time, or the time times k. Okay, they also changed, if you noted, from N, the years, to T. I'm not sure why that is, but so T is years here, just the letters they use. K is the times per year. R is still again the rate. P is still the principal. Okay, so these are really important equations we're using here. Okay, and then the next one, the last one we're really going to talk about this chapter is, and you probably have heard of this one before if you've done any kind of finance classes or talked about finance. It's compounded continuously. Okay, so compounded continuously would be A equals P E R T. We sometimes call it, this is sound weird, but sometimes we call it PERT, just because it looks like that word. But these are exponents. Notice that in finance, everyone's going to know what the letter E is. So if you're studying business, this is your introduction maybe to the letter E, or a natural log. But there it is. It shows up in the business world. Okay, so again, all kind of the same letters here. This is the principal. E is a number, a value in your calculator, like 2.7 something or other, 1 something. R is the rate. Of course, you always want to write it as a decimal. T is time. Okay, so those are the three, if you want to write down those three equations, those are the ones that we're going to be using for all of these examples. Okay? All right, so let's move on to the first example. I've already written it out, so it saved me a little time. So, found the amount, A, accumulated after investing a principal, P, for T years at an interest rate, R, compounded annually, also for simple interest at the same rate, R. So, looks like they went ahead and changed that letter N to a T, so we'll do the same. So here we're looking at compounded annually. So we'll go back to this compounded annually equation. Okay, and we're going to write that down. So A equals, terrible A, sorry about that. A equals P 1 plus R to the N or the T, it's whatever the years are, okay? I got this other book, and it seems like they change their mind sometimes. Okay, so let's fill this in. So 2,700. We want to write the rate. We want to write the rate as a decimal. Remember, write it as a decimal. So 0.05. And then the time, or the years, for the number of years, T is years, right, 4. So if I put that into my calculator, I get 3,281. Okay, so that was the first question. They asked compounded annually and also for simple interest. So the difference between this is when you compound it annually, continuously, compound it at the different values that you get. When you do it with the simple interest, you ignore the effects of compounding. You just keep multiply. You just multiply it by the percentage, and that's it. Okay, so the difference with simple interest. Simple interest is called simple because it ignores the effects of compounds. So big, I must totally mess that up. Sorry, I'm reading and writing at the same time. Ignores the effects of compounding interest. Okay? The interest rates just based on the principal. Okay? And then for compound interest, which we just did here, this is compound interest, just to give you an idea of the difference. The interest charge is based on the original principal plus the interest accrued on it. Okay, so compound interest includes the interest earned on the interest itself. And that's what you want to do. You don't want to do simple interest. Anyways, we're going to show you why. Because simple interest would be, here's the equation for simple interest. Sorry. Okay, so above we're going to write, so this is just simple interest. We're just multiplying the interest, the rate times the time, and we don't care about, continuous, compounding it and using the interest at all. Okay, so if I do the math here, I get 32.40. So as you can imagine, we just simply, the principal was $2,700. As you imagine and get larger sums of money, you definitely want something that's compounded annually or compounded at all, whether it's quarterly, annually, whatever. So, like your 401k, you guys, when you get a job, you will have to think about retirement, things like that. That's coming in, 4 or 5 years. So pay attention to how this looks. Okay. Let's go on to the next question. All right, so find the amount A accumulated after investing a principal P for T years at an interest rate R compounded K times per year. All right, so I'm going to go back to this. This is that equation we're looking at right here. Okay, so I'm going to write it down. And it looks like they gave me everything I need. So I'm just going to fill it in. So I'm looking for finding the amount A. So I'm going to fill it all in. Should be pretty easy. Of course, remember I want to use a decimal. No, T is okay. And then this is times. Sorry, I plugged it around it. It'll be better. Okay, and then I'm going to plug it into my calculator, which I'm going to do right now because I did not write down the answer for this. Okay, so I got 348.23 cents. Okay, make sure you round how the directions tell you to round. All right, next question. How much time will be needed for 24,000 to grow to $24,000 to grow into $27,858.11 if deposited at 5% compounded quarterly? Oh, you know what? I think I skipped a page. Let me go back. Sorry about that. I got ahead of myself. So let's find the amount after investing a principal, so many years, and an interest rate compounded continuously. I knew we hadn't used this third equation, so I skipped a page here. So we're going to write the equation compounded continuously. Here it is. No surprise if you wrote this down. Okay, so I'm just going to fill it in. Remember, we have to write it as a decimal. Okay, I'm going to go to my calculator. If you don't know where the E button is, just so those of you, it's right above the natural log button on the left side of your calculator. Okay, so I'm actually doing that calculation right now. Okay, so I got an amount, $23.98.71. Again, round whatever it tells you to on the math Excel. All right, now we're going to get to this problem. How much time, so what am I solving for here now? I'm solving for time, will be needed for 24,000 to grow to 27,858.11 if deposited at 5% compounded quarterly. So I am going to use the this equation right here, K times a year. Quarterly is how many times a year? That would be 4. So hopefully you can remember that quarterly is 4 times a year. Okay, so I'm going to write out the equation. Okay, and I'm going to fill in all the information. So I want to get in the end 27,858. You have to be real careful with these last two problems I'm going to do, because you're going to have to wait till the very end to really do some of the math in the calculator, because you can't round. So how much time? We're looking for T. So there's what I'm looking for, time. Okay, so I'm going to divide this side by 24,000. Okay, so that goes away. I'm going to do the math in here. So let me get that number real quick. Okay, so this is going to be 1.0125. Okay, so let me write this out. So I've got 27. Okay, and the reason why I'm not dividing this yet, because I don't want to round it. Okay, when you round, you're really probably going to get yourself in trouble because we don't know what the exact answer will be. Okay, let me take a step back real quick. Let me erase this for a second, because I need to leave a little space, because I'm going to show you how we're now going to apply what we learned in the last section when I showed you 2 ways to do it. This is the way I would do it. I would put a log and log, okay? And then I can use my properties to do this down the, over there. So I'm going to have log, still with this stuff in it. I'm not going to rewrite it because I'm running out of room. And this will be 4t log. Okay, and I'm looking for t, so I'm going to divide this whole side by 4, so get rid of 4, and log. Okay, so I'm going to have, actually let me write this. So right now I have t equals log, I need 27, 858, 11 for 24. Oop, one too many zeros. 24,000. And I'm dividing it by 4. See, that's where the 4 came from. Log 1.0125. Okay, and if you don't round, you should get exactly 3.000, blah, blah, blah. So 3 years is your answer. Okay, again, you can't round. You kind of have to just write it out and then go to your calculator. I do this part first. I hit enter, and then I do this with parentheses around it. If you forget the parentheses, it probably will change the answer. So try to remember to do those parentheses. Okay, last question. What interest rate compounded daily, so that I know what equation I want to use now, is required for a $27,000 investment to grow to $47,500 in 4 years? So I'm looking for R. Okay, so let's write out the equation that we know we're going to use. Oh, sorry, that's okay. All right, and then we're just going to fill in all of our information. I don't think I need this right here. And we're going to do it just like the last problem. It's a little trickier because we're looking for R, which is kind of in the middle of our problem here. Oh, sorry. K is not 4. K is this daily. So K is 365. And this is 365 times 4. Okay, so I'm going to divide 27,000. So that gets rid of that. All right. So I'm going to have 47,500, 27,000. And I'm going to have 1 plus R to the 365. And then 365 times 4 is going to be 1460. Okay, so now you know when we have x squared equals, let's do x cubed because I've already used cube equals 8. We're going to take the cubed root here to find the answer, right? So it's kind of the same application here. We're going to take the root, but it's 1460 here to get rid of that exponent. And then we have to also do that to the side over here. Now, on your calculator, under the math button, let me look. It looks like math 5. You can do this in your calculator. Obviously, you can't do it in your head, so hopefully you find that. So right now I'm going to put this on this side. Remember, you don't want to round. Okay, so we're going to put that in the calculator. We have to still solve for R, so I'm going to subtract 1. So on this side, make this a little bit smaller. On this side, I'm going to have this. Subtract 1. Okay, and then I'm going to multiply this whole thing by 365 365 to get rid of the 365. So I'm going to take this whole thing and multiply it by 365. Okay, so I'm going to go to my calculator. I'm going to type this in really quick. So I'm going to go math, go down to the fifth one. I'm going to put 1460 in there. 47,500 divided by 27,000. I'm going to hit enter, and I'm subtract 1, and I'm going to multiply it by 365. And so that gives me, okay, and then you know you have to multiply it by 100 in order to find the percent here. So I'm going to times 100, and you get 14.13%. Make sure you're rounding and doing all that to the right decimal. Okay? All right, you guys. There's only 10 problems. Should be really straightforward. I did all of the types that I put on there. Okay? Love you. Hope you have had a great week so far.